Hi, I'm Lisa. This video describes my solution to a project for a three-tier architecture in AWS. So if we look at the architectural diagram, we see we have a VPC set up in the North Virginia region with two availability zones. Each availability zone has one public subnet and three private subnets. And in each public subnet, we're going to have a NAT gateway and a Bastion host. And then in our tiers, we have a web tier and an application tier. Both will have application load balancers and auto scaling. And then in our database tier, we have a multi-AZ database deployment. So in the console, in the VPC section, I created a VPC called Project VPC with a CIDR block of 10.0.0.0/16 in the North Virginia region. And the VPC is attached to our internet gateway, which I called Project IGW. And within our VPC, then we have two public subnets and we have three layers of private subnets, two each for web, two for app, and two for DB. And they're in alternate availability zones. And then we also have two NAT gateways, one for each availability zone in the project VPC in the public subnet of each. Then if we move on to the route tables, we have our public route table that the two public subnets are associated with. And then we have two private route tables, one for each of the availability zones. And then if we move on to our private route tables, they're set up to be able to communicate with the NAT gateway in that availability zone, and the subnets associated with them are the web, app, and DV private subnets in each zone. So if we move on to security groups, then I've created a Bastion security group, which will allow us to SSH into our Bastion host. I also have a test web server security group for testing purposes. And then the remaining security groups allow chaining from one layer to the next, from our ELB to our web SG, to our app ELB, to our app SG, and to our DB SG, so that each layer allows traffic from the one that precedes it. I've also added an inbound rule for the web SG and the app SG to allow SSH traffic from our Bastion security group. So now we're going to look at the database layer, which you can see from the diagram is in this tier. In DB private subnet 1 and 2, it's a multi-AZ deployment, and it is within the security group DBSG. So we'll have a look at the console now. So in the console, in the RDS section, the first thing I did was to create a new subnet group called DB subnet group. And it is in this VPC, which is our project VPC, in subnet, the two subnets in both availability zones. So we have private DB subnet 1 and private DB subnet 2. And then I went on to create a database. And the configuration is T3 micro, MySQL. It is DB name project DB, and it's a multi-AZ deployment with secondary zone US East 1B. If we go into connectivity, here's our endpoint, our port. The availability zone is US East 1A. We see our VPC here and our DB subnet group. It is in the DBSG security group, so we have a look at that. And the inbound rules allow MySQL Aurora traffic on port 3306 from our app security group and our test web server for testing. It's also worth noting that these two subnets are attached to our two private route tables, Zone 1 and Zone 2, which allows local traffic and also internet bound traffic to communicate with the NAT gateways. And that allows for communication with the internet for patch updates for both of our DB instances. So the first thing I did was to launch an EC2 instance in public subnet 1 of my project VPC, type T2 micro running Linux, and I use the same user data as the project spec. So I'm going to use this instance for testing the application, And the user data basically installs a LAMP server, downloads a PHP zip file, and unzips it. So now we're going to test that the web test instance that we set up in public subnet 1 is running and that we can access it publicly, test the application, and test the database connectivity. Web test is in the test web server security group, so it's open on port 80, and it is also, I've also given access to the DB security group from the test web server. So I will copy the public IP address into the browser and see if the application loads. And it does. And then if we click on RDS, and we can see that we're into the database as well. So we remove, and there, the database functionality is working also. So once I tested that the web application works and the database connectivity works, I launched 2 EC2 instances with the same spec as the project scenario. And from them, I created an AMI, one for each layer. So we have the web layer AMI and the app layer AMI, and they will be used later on in our auto-scaling groups to launch our EC2 instances. I want to launch a Bastion host into the public subnet of each availability zone. So for consistency, I launched an EC2 instance called Bastion host template, and from that I created an AMI called Bastion AMI. I then used that to launch 2 EC2 instances, Bastion Z1 in Project VPC Public Subnet 1 and Bastion Z2 in Project VPC Public Subnet 2. The Bastion hosts are in my Bastion security group, which allows SSH access from my IP address. So that's would be the IP of an administrator. I then terminated the Bastion host template because it was no longer needed. So then I moved on to creating the application load balancers. There's 2 in our architecture. One will balance requests to the web servers and the other will balance requests to the application servers. So the first setup is Web ELB, and it is internet facing. It's in Project VPC in public subnet 1 and 2. It's in the Web ELB security group, and it is using web group, which we set up as a target group in creation. The second is the app ELB, which is internal, and it is in Project VPC in private web subnet 1 and 2. It is in the app ELB security group, and it is using the app group target group that we created when we made the load balancer. So next I moved on to creating the auto-scaling groups. There's one for the web autoscaler and one for the app autoscaler. So I started with the web layer and I created a launch configuration called WebLC, and that uses the AMI that we created earlier, web layer AMI, and it is in the security group WebSG. And from here I created an auto-scaling group called Web Autoscale with capacity of 2, 2, and 4. It's using the WebLC launch configuration in subnets, which are Web Private Subnet 1 and Web Private Subnet 2. It's load balancing with web group, and the tags, the name will be Web Autoscale Inst. So now if we go to the instances, we can see that 2 EC2s have been launched, Web Autoscale Inst, one in US East 1A and one in US East 1B. So then I follow the same steps to create the app autoscaler, starting with the launch configuration app LC, using the AMI we created earlier for app layer AMI, and using our security group app SG. And from there, I created an app autoscaler called App Autoscale with a capacity of 2, 2, and 4. There's our launch configuration app LC. The subnets available to us are App Private Subnet 1 and App Private Subnet 2. And the tag, the name is App Autoscale Inst. And then we see, if we go to instances, we can see fired up are two app autoscale ints, one in US East 1A and one in US East 1B. So now I'm going to test that our web ELB is working. So I've copied the DNS name, pasted it into a browser, and the application is working, and we are in US East 1A. So now I've reloaded the screen, and we can see that the instance ID has changed and the availability zone has changed to US East 1B. So our load balancer is working. So now I'm going to test the load tester and see if our auto scaling group is working. So I'll leave that running for a while. So our load tester has been running, and we can see in CloudWatch alarms that there was an alarm for CPU utilization greater than 60, which was what we set in our target tracking. And if we look back at the console, our web autoscaler has gone up to 4 instances, and we can see the 4 web autoscale instances running or initializing. So now I'll stop the load tester, and because we have allowed scale in, we should scale back down to just 2 web autoscale instances. So here's the graph that shows the CPU utilization for our 4 instances, which hit a peak and has now gone right back down. So after a while, we can see that our web autoscale group has returned to 2 instances, and we can see in the activity history that it has terminated 2 EC2 instances. And we can also see that those 2 web autoscale ints have been terminated here in this part of the console too. Finally, I wanted to test SSH access to my web server and my application server via my Bastion host. So using SSH and SSH pass-through, I was able to log into my web server, I was able to log into the application server, and from there I was able to access the database because I have permissions through the security groups.